got it? Got your notes up? All right. So we can use a matrix to organize the vertices of a triangle, the coordinates. And we did this earlier. I think it was on Monday. You can use matrix operations to transform figures such as a triangle, just as you transform the graph of a function. So this matrix represents the vertices of triangle ABC. So we did this before, and let's do our arms. What comes first? Rows, and then columns. Okay, so we're going to do our rows and columns. So I want you to look at the matrix and try to write down what the vertices are. A, write down the coordinates. B, write down the coordinates. And C, write down the coordinates. And think about your rows and your columns. Okay, all right, cool. All right. You got it to work now? Yeah. Yay. Okay, was it just restarted? Yeah. Okay. All right, Gabe, what would be the vertices of the point A?
Isn't it just -3 and 2?
Yeah, there you go. -3 and 2. How about B, Humira?
1, 3.
1, 3. And C, Isaac, what would that be? 2, -2. So can anybody tell me, what do the rows represent in the matrix? Yeah, Mia? Good job. Okay, the rows are the X and the Y. And then my columns are the points, A, B, C. So go ahead and plot it. Plot your 3 points. So if A is -3, 2, that's left 3, up 2. B is 1, 3, so it's right 1, up 3. C is 2, -2, so that's right 2, down 2. All right, graph a triangle now that has been shifted 3 units left. So let's circle back to geometry and maybe use a new color. Okay, on your iPads, pick a new color. And take the triangle ABC and let's shift it left 3 units. All right, so Cal, what did you need to do in order to sketch the new triangle?
I just left out my old points and just did the left 3 units.
Yeah, okay, so in A, if you just moved it left 3, does anybody remember from geometry, what notation did you use in your geometry class? Yeah, Humira? Good job. Yeah, that's an A prime. So then let's do it right here. What are the coordinates then of A prime? Mackenzie, if you can literally count over, what would be the coordinates of A prime?
It would be -6, 2.
Yeah, -6, 2. Then let's do this with B. And we'll call it B prime. Then what are the coordinates of B prime? Hannah, if you count.
Would it be -2, 2? I mean, -2, 3.
Yeah, -2, 3. And then let's count left for C prime. All right, William, what do you get for the coordinates of C prime then if I move it left 3?
-1, -2.
Yeah, -1, -2. All right, so now this is some geometry, and we're going to try to connect it to matrices here. What kind of matrix operation could I do that would take the original matrix and give us the resulting 3 points? Yeah, Cal?
I mean, you subtract 3 from the x, from the, like 3 from the first row of the matrix.
Yeah, okay. So I'm really impressed there because I'm not subtracting 3 from both the x and the y's, right? Okay, that was an excellent catch. So how about like this? And then that's giving us our -6, 2, -2, 3, -1, -2. All right, looking at this one, now let's look at letter E. What if I give you the original triangle and I have you adding -4 to the top row and -3 to the bottom row? We're not going to sketch it, but I want to see if you can describe what transformations are happening.
Left 4, down 3.
Nice job, Matthew. Yeah, so that's going to be left 4 and down 3. All right, letter F. Let's see if you can remember some geometry. What if I put a 2, that was our scalar, we described that on Monday. If I put a 2 out front, can we use some geometry vocabulary? What would be the transformation of 2 times? Anybody remember? Yeah, Brennan?
Dilation.
Good job. Yeah, that's a dilation of 2. All right, and then here's just another word problem for us to look at because matrices are used in the real world. Like that's what they're what we need them for. So example 2 says the school cafeteria offers a choice of ice cream or frozen yogurt for dessert once a week. During the first week of school, 220 students choose ice cream and 20 choose frozen yogurt. During each of the following weeks, 10% of the frozen yogurt eaters switch to ice cream and 5% of the ice cream eaters switch to frozen yogurt. How many students will choose each dessert in the school each week? So you can actually use a matrix equation to find the answer for the second week. So the 220 and the 20 represent the 220 who chose ice cream and 20 who chose frozen yogurt. If in the first week 10% are switching, why, can somebody explain, why do I have a 10% here followed by a 90%? What does that mean? Yeah, Brennan?
Means that 90% stayed on yogurt or whatever.
Yeah, the 90% stayed and the 10% switched. Likewise with the 5%. So if you notice, I've got, let's go ahead and first of all, can I multiply those 2 matrices?
Yeah.
Let's find, well, how do you know?
Because it's a 1 by 2 and a 2 by 2.
Oh, yeah.
Oh, yeah. Okay. So remember, and I caught myself earlier when we did a problem. I was like, we were starting to go, and I was like, whoops, I forgot. We got to check our dimensions. So the answer is going to be a 1 by 2. So if you have a calculator, go ahead and grab a calculator, and let's do the matrix multiplication. And remember, this is going to be 1 row with 2 columns. now you gotta multiply your first numbers, so take your 220 times 9.95. And what I do is kind of jot that down, because 209 somewhere, because it's a lot to remember. And then you're gonna take 20 times the 0.1. So you're gonna do plus 2. And that's what's gonna go in the first row, first column. Okay? And so do you see up on the board where I have it's 1 row and 2 columns? It's 211 and, let me see. Yeah, 29, got it. All right, so the top row is the ice cream eaters, the bottom row is the transition. So we end up with, in the second week, 211 and 29. All right, so any questions about multiplying the matrices? Okay, so if you will clear off your desktop, if you want a calculator, you can have a calculator. But we're going to do a little skills check.
Do you think I need a calculator?
I don't think you need one, but
I don't think
I have calculators by the window. Why don't you just try it for now? And if you feel like you're gonna need a calculator and you don't have one, you can go grab one of mine. You wanna try it?
Thank you so much.